Let's modify this example and say, how about we print when count is greater than 0, say positive. How about we say else, otherwise, right? We say then otherwise count is negative, positive or negative. But this would be definitely incorrect, because if it's 0 like we have it, it's not 0 and is not positive. I mean, it's not negative and it's not positive. 0 is not positive or negative. 0 is 0, right? So here no chance but to say negative or 0. Let's make sure that it works. We check our condition. I build and run. Okay, so this works. It prints this right now. The output is this, right? Count is negative or 0 after I execute it. Here's something interesting to know, because you may be able to see also, in fact, I would like to come back to this example in a second, so I will just duplicate it and name it version 3, because I'd like to come back to it in a second. But it's also possible to write code like this. If count is non-zero, otherwise count is 0. Just remember this. When a variable or expression is used in your if statement, which is condition, you can use an integer like this. Just remember, anything which is non-zero, -1, -100, +500, 1, any value, is true. So any non-zero value gets converted to true. Only 0, like I have it right now, gets converted to false. Okay, so integers can be converted to Boolean without any predicament in C++ and used as expressions themselves. So basically, if count, the meaning of this is the same as I said, if count not equal 0. That's exactly the meaning of this short form of it. If count not equal 0, then count is non-zero. Otherwise, count is 0, right? So if I get rid of this, or like if I write it side by side like this, so most of people, I guess, would write it like this, because the shorter form, the meaning of this is the same as this, right? So I think this is preferred, okay? However, a lot of Java programmers would sort of disagree on this style, because in Java you are forced to do this, because in Java conversion between Boolean and integer values is considered to be unsafe, and in Java this is not possible, right? However, I think that most of C++ programmers would choose this form, and C of course as well. Just a little note like this, right? So this is quite possible, and the meaning of it is that it's non-zero. Non-zero makes true. 0 makes false. So for instance, if I said -100 over here, this would be true. It would say it's non-zero, right? That's if we run it. And only if I initialize it with 0 or keep it 0, then it would say count is 0. Okay, so now back to the previous example. So this would be our main version 4, right? I'll push it down a little bit, move it out of the way, and back to this example. So remember, we said greater than 0 is positive, otherwise negative or 0. So how would I write this to print positive, negative, and 0 as separate, separate display? For example, I modify it. So I want to accommodate one extra case, if you will, right? So I want to say negative is negative or is 0. I want to have these three separate statements. So this, I want to separate these two. That's my plan. So in order to do this, just a reminder that when we say if like this, basically we have over here we have, in general, we have condition, right? We have condition over here. Here we have some statements, right? Let's just say statements, right? And else is optional. But what else wants, else over here also wants a statement, right? This is what else wants. It wants a statement, right? So if condition, statement, statements, whatever I do, then else also wants a statement. And remember, I want to convert my else into two different parts. So I want negative and positive. So this whole statement could be an if statement with its own condition, and I say if count is less than 0, then count is negative. So that works, right? So you see that if with its own else can be chained with another if statement. And finally, we say that if none of this worked, just like basically otherwise, else, right? If none of it worked, it would be a 0. So that's a possibility, I guess, right? So when you have something like this, if condition, else, if another condition, you can continue else, if another condition, and you can do it many times. And finally, you can have an else. Essentially, this type of structure provides ability to implement mutually exclusive cases or mutually exclusive choices, right, based on our conditions. So this is greater 0, this is less 0, and finally, you know, I could have even written it like this: if count is 0, right, then count is 0, right? But because this is the only choice that's remaining after filtering out greater than 0, less than 0, then of course this is just probably not necessary. So simply else would take care of it. That's all we need, I guess, in this situation. Checking for 0 or non-zero can also be if I kept this expression. If count 0, remember, this would give you a non-zero values. I would evaluate to true, but we can also say not count. So not count means that if count is 0, right? So over here, for instance, right, we could have done it this way, right? In this prior sample, this worked, but let me give you a copy of it. And if I said if not count, exclamation point reverses true becomes false, false becomes true. So if I do it like this, then the meaning of it changes to the opposite. Not count means what? If count is 0, this would evaluate to true, and this would I'm sorry, once again, if this is 0 like this, right, then not, so 0 becomes false, and then not false becomes true. Okay, so that would say count is 0, right? So not count evaluates to true if count is 0. So I show it to you because this is also a lot of code is using form like this, right? So this becomes true only if count is 0. So this is a very typical check for an integer value for 0. If not this thing, then it's a 0. Okay, so just this reminder over here and back to this, right? So again, I could have written it like this. In fact, let's verify that it actually does indeed print count is 0 because it was 0 to begin with. Let's build and really quickly run it. It says count is 0, so that's exactly what the output is right now. So this prints this thing on the screen. If I change it to say to -1, it should say that count is negative. Right, count is negative. This is what gets printed. We verify that, and finally, if we say +1, then it should be a positive thing, right? By the way, just like negative -1, unary minus exists to complement -1 with there's also +1. Of course, the meaning is the same as this, right? You don't have to use it at all. So that should simply say that the count is positive. Yes, it is positive. So this works. Okay. Let's go back to 0 like it was.